Hello and welcome to O'Plattery Videos, here to help you study, learn and succeed. Today's video is about solids, liquids and gases. Really simple and straightforward, but something quite a few people get wrong. So we're starting with solids. Solids are quite easy to get the hang of when you look at them. They're basically, it looks like layers of marbles all arranged in straight rows. Those layers of marbles are underneath each other, so it looks dead easy. And then you keep on drawing rows and rows of circles to show a solid. This shows you that the particles are always close together in a solid. That's really important because that then tells you about their properties. They've got a nice real regular arrangement. If you think about you in school, for example, it's like you sitting in rows. Again, that tells us about the solids. So it gives us an idea about what they're like. So this means that because they're close together in a regular arrangement, they're unable to move those particles. They stay in place. But in terms of their movement, they are able to just literally move a tiny bit and vibrate on the spot. That's important when we're heating them up. The more vibration they have, the hotter they are. So far, those are our important properties about them. Because they've got this regular arrangement, they're fixed in place, there's obviously no space between them. That lack of space means that we can't compress them either. That's another important property. So we can't compress them. So this means that because they're in a fixed shape, they can't flow, they don't move, they can't be compressed. That's why we use them for the things that we do. So an example of uses for them would be in building. In building, we would use them for our foundations or our walls. They're nice and solid. So, our key points. They're a fixed shape, they can't flow. And because of that, they also can't be compressed because they're not able to move. So that's our solids. Liquids then, a little bit more movement in a liquid. Particles I always think of look a little bit like kind of wiggly jelly worms stuck together, and there's a little bit of space between them, but again still pretty close together. Okay, so we've got they are close together. Again, that will link us into their properties. Unlike the solids that were nice and regular in their order, these you can see aren't regular arrangement, so they're random. They've got a random arrangement of particles, and again that will lead us into their properties. They are able to flow around each other, so they can move. But the same as solids, they have strong bonds that are holding them together. So we've got strong bonds keeping them close together. That's exactly the same as in a solid. Okay, so they're similar but different. So in terms of our things, well, if they're close together, we also can't compress them. Again, it's important in their properties. Where do we use them? Well, we can use them in, for example, car brakes. And it's that lack of compressibility that's really important there. So, key properties, they can flow and they take the shape of the bottom of anything they're put into. So if we have a beaker, they will fill this bottom space. So take up the shape of the bottom of the container. And that's because of this random arrangement that allows them to move. Okay, because they can move, they can do this. If they couldn't move, they couldn't. That's important about them. And again, as we've said, they can't be compressed because they are close together. So again, another important fact about liquids. We then have our gases. Gases, loads and loads of energy, so the particles are far apart and they're spread out. So they're far apart. Later on we'll talk about pressure, probably in a different video, but the pressure is when we push them close together. You can see that they've got a very random arrangement. Again, important for our properties. Because they're like this, they can move in any direction that you want them to, and they can move really quickly. So they move quickly in any direction. This is why when a smell appears in one part of a room, we all eventually smell it, because it moves as the particles move around. Because of this, we can say we've got no bonds between them. This is what allows them to move. If there were bonds, they couldn't. So exactly like solids and liquids, because there are bonds there, they can't move. Rather than just filling the bottom of a container this time, they will fill an entire container. So if I have a balloon, my particles will fill the whole balloon. So they'll fill an entire container. So that's different from before. They'll spread out, they'll fill the whole container. This is because of this ability to move. If they couldn't move, they couldn't do this. If they're able to move and they've got this random arrangement, this is why we can compress them. And that compressibility is also important. So we can compress them. Because they're far apart, we can squeeze them into a small space. So it can be compressed. So we would use them to fill a balloon. It's the air that we breathe. If we then summarise it down, so we're going to have our solids, our liquids, and our gases. The summary kind of takes into account all of the stuff that we've said so far, but there are important points in all of them. So our diagram, and that's often what we're asked to draw. So a diagram for a solid, regular arrangement of particles, all nice and neat, all in a fixed pattern as I said, looks like marbles laying up. Liquids, more space between them, but still close together. As I said, kind of wiggly worms. Then your gases, well, random and all over the place. How are our particles arranged? So in our solids, our particles have a very regular arrangement. In our liquids, it's more random. So you can see that the amount of random is kind of increasing as we move across. And then in our gases, they are very random. But also we just call it a random arrangement. We then need to know about how they will move. So movement. Well, we said these guys just vibrate on the spot. Not much they can do. They're vibrating on the spot. Our liquids, well, they can move around each other. And these were able to flow. This is why water will flow. Okay, and then our gases move randomly in all directions. And it's quick. Last thing is then about really how close those particles are. So these guys, really close. Okay, these ones, they're still close, but there's a little bit more space between them. These are far apart. And finally, our bonds. These are strong, they're holding them in a fixed position. There are no bonds here at all. They're able to move in all directions. They still are bonded together because they're held closely to each other. There's our simple summary of solids, liquids and gases. Thank you for watching Oplatry videos. See you soon.